Good morning, everyone. My name is P. Shivashankar. I am working as Assistant Professor at Krist Jyoti Institute of Technology and Science, Jangaon. So, I am here to discuss about a new basic subject for a civil engineering student, which give you a detailed description and detailed knowledge of a surveying subject. So now I am going to deal with a subject of surveying or engineering surveying. So which is a basic subject for a civil engineer. So now I want to give you some introduction regarding this surveying subject. So in this course, we are going to discuss or we are going to deal with these particular points. So where the first thing is introduction to surveying. Introduction to surveying. And whereas next we will deal with basics of surveying. Types of surveying. Chain surveying. Traversing and contouring. Leveling, tachymetry, areas and volumes, new methods or advanced methods, in surveying, advanced methods in surveying, photogrammetry, and modern techniques in survey. So these are the topics that we are going to discuss in this particular course. So that is surveying. And after completion of this particular course, so in this regard we first go for introduction to surveying. So what is surveying, the definition, and what are the basics of surveying, what type of equipment that we use in the surveying, and what is the terminology that we use in the surveying is known in basics of surveying. Then we will go through some different types of surveying, where they include chain surveying, compass surveying, prismatic surveying, and leveling, so on. And then we go for the chain surveying, traversing and contouring. So how to fix a particular point by using traversing, and how to identify a heat area by using contouring. And then we go to the leveling, so where we calculate and where we measure the vertical distances of a particular object. So that object may be a natural object or that may be an artificial object. So next we go for the tachymetry, which also deals with the distances and heights of a particular object. And then areas and volumes. So how to calculate the area of a particular ground or a particular thing. At the same time, how to calculate the volumes. Then new methods or advanced methods in surveying. So nowadays, so actually we are using some different types of surveys, different types of techniques in the surveying. So where that may take maximum time for the completion of work. So whereas here these new methods or advanced methods will reduce the time that required for the completion of survey, as well as which gives the maximum accuracy in calculations. Next, photogrammetry, which deals with the representation and taking the data of a particular objects that which are available above the ground level in the universe. And then we have the modern techniques. Here we have some modern techniques, so which will give you the information without the manpower. Means, for suppose if you take some instruments that which are introduced in the surveying, so they are really very advanced and very important instruments which they give at a time you can complete a number of programs in that particular thing. So that is why we call it as the modern techniques that are involved in the survey. So see, now I would like to tell you one thing that after completion of this course, after discussing all these particulars in this particular surveying course, you people will be able to do something. Now, I will tell you what are the things that you people are going to do after completion of this particular course. So, you will be able to do after completion of this. After completion of this course, you will be able to do or able to do. First thing, what we are able to do? First thing is that you people are able to take the measurements and observations of a particular thing or a body with accuracy, with not a normal accuracy, high accuracy. This is the first thing that you will do. And then you can calculate it. You will be able to calculate it. To calculate it with good accuracy. Means after studying this, after taking the observations and measurements, you will be able to calculations. You will be doing calculations with high accuracy or good accuracy. And then you will be able to understand the principles. Which principles? Especially here the working principles. Working principles of equipments used in survey, and then not only the equipment but also the errors, principles of errors involved in surveying, and then corrections, principles of corrections. So after completion of these particular, you people or all the students are able to understand what are the working principles of a particular equipment that which is used in the surveying, and then what are the errors that are occurred in the surveying equipment, and then how to apply the corrections for that. So this can be achieved after completion of this course. And then the next one is you can identify, you will be able to identify and interpret the results using modern techniques. Modern techniques involved in the survey. So not only this, but also in addition to this, you can calculate areas, comma, volumes, comma, distances and heights. Further, observations. So these 5 are the major achievements or major course outcomes that a particular student or that a particular person can achieve after completion of this particular course. So now let me introduce about surveying or engineering survey. So we will see what are the definitions of surveying and what are the principles and its objects of a survey. So let me tell you the definition of a survey here. So in our day-to-day life we have so many different types of surveys. So where see generally the surveying stands for the census. Census is one type of survey where we calculate or where we estimate the population. For suppose like if you go for the hydrostatic survey, so where we can take the pressures that are involved by the water and its velocities, whereas the surface tensions. So some particulars which regard water can be calculated in the hydrographic survey. But here likewise, here in this survey, so this is a different type of surveying where it can be defined as definition. It can be defined as so surveying is an art of determining the relative positions on the ground by taking linear or an angular measurements. This is the common definition, not a brief definition. So definition of a surveying is an art of determining the relative positions. Please stress this point. Relative positions on the ground. Please stress this particular point also. On the ground by taking linear or angular measurements. So if I have a difficult detailed definition of this particular surveying, surveying is an art of determining the relative positions, not exactly on the ground. So that may be here, this may be below the ground level, or that may be on the ground level, or it may be directly above the ground level. Okay. So if you want to study this particular survey in detailed way, so this is not an exact science which deals with all these measurements and calculations, but surveying is a part of geoinformatics. This is not. Surveying is a part of geoinformatics. So where geoinformatics stands for. So here I can categorize the geoinformatics. So where geo stands for the earth features. In the sense, geo stands for the study of earth. or the features that are available over the earth, it stands for the geo, not exactly over the earth but also below the earth level. And whereas the informatics, so informatics here, this is really very important in the surveying. If I separate this particular informatics, so this can be written as inform plus matrix. I can write this one as inform plus matrix. So where inform plus matrix means if I complete this particular term information plus matrix. So see, taking the information or gathering the information regarding geo feature. Geo feature is at the feature. So taking or observing the information of an earth feature, and matrix in the sense measurements of that particular earth feature is known as geoinformatics. So geo in the sense feature of an earth. So this feature of an earth. So if I take earth features directly, so these are all natural features. Natural features are there. But now the universe is day to day a construction. It is growing. So therefore, apart from natural features over the ground level, when I go for the different elevations, so if I take this is the earth, so I am considering this particular part of an earth. So this may contain the ponds, this may contain the forest, this may contain some artificial buildings or artificial structures. So likewise, now the earth planet, it has different features, so like both natural and artificial features. So see here, geo. So geo in the sense that regarding the earth. So now taking means studying of natural features. Along with these, we go for the study of artificial features. Artificial features in the surveying subject. So here natural features and artificial features now, and gathering the information or taking the information from these particular sources, either that may be natural or that may be artificial, and finally measuring that particular one. Measuring means measuring the feature. E stands for geoinformatics. So why I am going to represent you people that surveying is a part. I am representing that the surveying is a part of geoinformatics. So where geoinformatics, why I am having a geoinformatics in the sense, geoinformatics generally dealing with all the features that are available on the earth level. That may be a building, artificial or natural, building, valleys, trees, forests, everything, whatever it may be. So taking the information of that particular feature and measuring to what extent it is spread. For suppose if I take the sea, so sea water is covered over the ground level at some extent. We don't know what is that extent. When I take the forest, each and every tree it will be having a particular height. So at what height, up to which height the tree is good, I want to take. So here, the measurement of that particular object, to what extent it is spread over the ground level, to what extent it is grown over the ground level, or at what extent it is located. So these all can be identified and calculated, detailedly studied in geoinformatics. But by taking the subject of surveying or by studying the subject of surveying, we may not achieve 100% of geo information. We don't get 100% of information in this particular surveying, because 100% of fulfillment, 100% information fulfillment can be done in geoinformatics system only. So that is the reason why I am calling surveying is a part, in the sense where I can take a little bit of information, not a total 100 extension of information, but that may be a 50%, that may be the 60%, that its own limitations to which it calculates, to what it calculates, and so. That is why I am calling surveying is a part of geomatics. So where geomatics is this one. Now this is a part of, surveying is a part of geoinformation of determining the relative positions. What are those relative positions then? So relative positions are also very, very important. Here we need to stress this. Relative position is something. For suppose if I stand here over the ground level, if I ask you people to calculate my height, so what we do generally, we calculate my height from a particular point, from ground level. So where I stand, I take the full level, you take the first one. At my head level, you take the second point. So the distance that is bounded between these 2 points. So see here, let us take this is a human being. So here we stand over the ground or over the surface. If I ask you people to measure the height, so you calculate something. You will calculate or you will measure the height, and you may send that the height of the particular person is 5 feet. So you people are telling here the height is 5 feet in the sense how you are going to tell the 5 feet is the height of this particular object. This may be an object, this may be a human being, whatever. So see here, this object is very, very important. Do you go further measuring this particular height from somewhere else here? No, we don't do that. We are taking a particular point where the person is standing, and we are using this particular point where the person is standing as a reference point. As a reference point. So from that reference point, you are measuring the height of the particular person. So we call this particular reference point as relative positions over the ground. Relative position. So likewise, first suppose you will be having a home. So home it contains itself you people have some home. So this is the compound wall of our home. This is the compound wall of our home. So let us take this area. Let us consider now this blackboard is a town, or this is a street which contains number of homes. So in that each and home, different home itself, it will be having some points. Means end points, control points. Means we must have to construct the building in our side only, not in others plot. In our plot. So please, if you want to identify what is your plot, you need some points. So which represents, if you combine all those points, if you enclose a particular area between those points, you will get the area of your land. So we call that points as relative positions. First, suppose you take the building. So a rectangle. Let us take a rectangle. This is the point 1. This is the point 2. This is the point 3. This is the point 4. Okay. So we call these points are the relative positions. Relative positions. Or any one of these points may be the reference point. So based on that, you are able to draw the rectangle. So likewise, if I go for the calculation of a hill, let us take there may be a hill on the roadside area. Let us consider that here I have the ground level. So I am traveling from Hyderabad to Bangalore. So in that way, I have a hill beside the road. So means you need to locate. So this particular portion, this particular hill will be having 0 height initial point. So when you go for a distance, so the height of this particular hill will be different. Means the particular feature, this is the particular feature for which you will be having a number of relative positions. So because of these relative positions only, you can interpret this particular model. You can interpret this particular model in a sheet. So we call these points for relative positions. So these relative positions may be located exactly on the ground level. We don't know. First, suppose if I ask you people to calculate the height of the building, let us take this is a 3-story building, includes ground floor plus 2, G plus 2 building. If I ask you to determine the height, measure the height, you take some reference points at the bottom. So we call this one as the relative position. So if you want to complete the section, you need another point at the top of the building, then only you can measure the distance between these 2 points, and we represent that particular one as height of the particular object. So this height can be measured. You are able to calculate this height because only reason that you identify the two reference points. If you don't know the reference points, automatically there may be no possibility to calculate the height of the building. So likewise, not only the building but also the everything. So we call this particular phenomenon, identify these particular relative positions. Either that may be below the ground level at any extent, or that may be above the ground level at any extent, or exactly on the ground level by taking which one? Linear and angular measurements. Linear or angular measurements is known as surveying. Now let me tell you what is linear and angular measurements. What are the linear and angular measurements? Here the surveying is also plays a very good role in the calculation of linear and angular measurements. That is also very important. So which represents you the geometrical position of a particular object. Means representing its height, representing its length, representing its width. So we call all these one as the linear measurements. Okay. So I would like to tell you people that so I think you understand what is the definition of particular surveying, right? So now we will see what is linear and angular measurements. Linear and angular measurements. Linear, angular. Linear measurements, angular measurements. So where linear measurements are nothing but the length, breadth and height. Length of an object, measuring the length of an object, or measuring the length of a ground, measuring the breadth of the particular object, measuring the height of a particular object. So means on the ground level, means we can measure in x-axis length, width and thickness, depth, height. So in different axes. Okay. So these particular phenomena, these measurements of length, width, height are known as linear measurements. Whereas angular measurements in a sense representing the angle between any two consecutive points from a reference position is known as angular measurements. So angular measurements are generally radians and degrees. Radians and degrees. So angular measurement. For suppose if I want to calculate the angle bounded between two consecutive points. So suppose this is one point, this is another point, with a fixed reference point somewhere else here. If you measure the angle bounded between these two, let us take this is some theta. So we call this particular theta. This theta may be in degrees or this theta may be in radians. So here I am extremely sorry. Here this length may be in meter, or that may be in centimeter, that may be in mm, or that may be in feet, any type of system. That may be in any type of system. So likewise here, theta may be in radians or degrees, and we call this particular type of measurements as angular measurements. So by taking linear or angular measurements above or below the ground level or exactly at the ground level, by following some fixed reference points, if you measure something or if you describe something, that means that something may be an object or something may be a feature directly over the ground level. So we call that particular phenomenon as surveying. Okay. So now by this you people are known what is surveying. So now we will see what are the objects of surveying. Why actually we need to survey. So I would like to tell you what are the objects of surveying here. I would like to tell you what are the objects of surveying. objects of surveying or objectives of surveying. What are the objectives of surveying? So surveying objective in the sense is output. What is the output of a survey? So the major and the preliminary objective of a survey is to prepare a map. To prepare a map or to prepare a plan. To prepare a map or to prepare a plan. So nowadays you can see in your day-to-day life, there are so many maps are available. Even in our mobile also, we have Google Map technology. So where we will be having so many different types of features. Means you can able to see what is the location of valleys, what is the location of rivers, what is the location of seas, what is the location of earth, what is the land covered by the particular object. For suppose some part of earth may be covered by some trees, means forest. Some part of earth may be covered with built-up area, means construction areas, and some part may be built up with parks, and some parts may be built up with some industrial areas. So whatever may be the matter here, to prepare a map or to prepare a plan is, so we have Google Map, that's why we can travel from one place to another place when we are new to that particular area. So this can be only achieved by the surveying. So a map is something where it will give you or simply I would like to tell you, map is a drawing which gives a greater or a large data information. So here data is nothing but the data regarding the computers. Here this data is regarding the features of Earth. Means geological data. So that geological data can be calculated or that can be given by the map. So when we come to the plan, so plan is a small drawing, which gives information of a particular object or place. This is very important. So map is, this may be in two-dimensional direction, or this may be in three-dimensional direction. But whereas here, this can be only in two-dimensional directions. So as you can see in your day-to-day life, generally what we do is, we ask the people to take the plan. What is the plan of your building? What is the plan of the road? So since the location of a particular object or the dimensions of a particular object, in which dimensional system? Only two-dimensional system can be interpreted in a plan. But whereas in a map is something which will give you the large area description, or which will give you an idea about a greater features, number of features over the ground level in a small paper. Then we call it as the map. So here the plan is having only the length and width. We don't have any depth. Why? Because this is not really in the three-dimensional direction. But when we get into the map, so map will give you the information on so many features like highways, buildings, roads, everything. So in three-dimensional system, even in three-dimensional, if you want to get in two-dimensional, you will get in two-dimensional. If you want to get in three-dimensional, you can also get in three-dimensional system. So to prepare map and to prepare plan are the primary and important objectives of our surveying. Okay. Then we will see why and what is the importance of survey. I am going to discuss now what is the importance of survey. What do you mean by the importance of survey? Why we need survey in our day-to-day life? So as I told you just now, it is really very important to draw maps and plans. They are termed as the objectives. But now I would like to tell you people that what is the importance of surveying. What is the importance of surveying? In what way it is important to a particular engineer, especially the civil engineer. So now I would like to tell you, this is really very important. Survey plays a greater importance in the built-up area. Or in any construction. And whereas the second one is in town planning system. And third one is for accuracy. So these are very important. First one is for built-up area or in any construction. So in any construction, how surveying is important. Generally, I would like to tell you one thing in a general way. First, suppose initially if you want to construct a building or if you want to construct our home at the site that which is available for us, what we do is first of all we look at the points. What is the area that we have? How much area we have to construct the building? That is the first thing. And then to how much extent we are going to construct, whether we are going to construct ground floor plus first, second and third, or we want to put it ground floor, or we want to put it ground plus first floor. So it's all regarding the height of the building, it's taking the height of the building. And where the first thing, plots deals with the length and width of the building. And at the same time, what type of material we have to take, and how we need to construct with the exact dimensions. So all these things are involved in the construction or built-up area. This is first one. And next, in town planning system. In town planning system also, if you want to lay a road in a city, or if you want to construct, if you want to go to any government project, first of all you need to take the town planning details. So then only, if you know the town planning details, then only you can identify, you can choose the location through which you need to lay a road. First suppose a road work is going on. So we need to choose a road. First suppose, let us take this is an area. This is a particular area in a city. So I am going to give you some information. So this particular one is any government building. So here this particular area is covered with all with industries. And let us take this particular areas with some shopping malls, and this particular area may be with occupants. So if you want to construct a new road project, you must have to see this particular plan. So by this plan, you may know what are the boundaries of this particular industrial area, government building, shopping malls, and occupants area. And how to connect all these buildings, all the features together by laying a road. So these all questions can be solved only because of the subject survey. And next, for accuracy. If you want to get accuracy, in ancient days we don't have any measuring distance and measuring equipments. We don't have any modern techniques. But now, even after getting the modern techniques in the surveying for measuring something, accuracy is very important, and that accuracy can be achieved by the subject survey. Doing something repeatedly will give you the accurate values. For suppose if you want to measure the length of a particular line from one place to another place, so do it for the first time, do it for the second time, repeat it for the second time, third time and fourth time. Now after 1 plus up to 1, 4 divided by 4 will give you the average value, and this is the exact value. And this will be the very exact value. So these 3 points were very important points in the survey. So because of these 3 situations, because to achieve these 3 conditions, we just go through the importance of survey. And next we see, we have completed the objectives of survey, importance of survey. Then we will discuss what are the primary divisions of a survey. We will discuss what are the primary divisions of a survey. So I am going to explain you the primary divisions. Primary divisions of survey. Primary divisions of survey. So what do you mean by the primary divisions of survey? See here, I have told you the importance of surveying, why it is important, what are the objectives of surveying, and what is surveying. So in all these 3 conditions, a general topic is the earth. General topic is this. For suppose if you want to measure the length of a particular object on the ground level. So if you want to measure a particular object height over the ground level for natural as well as for artificial features. So ground is very important. So now I am taking the earth, figure of earth or shape of an earth. So generally when we take the shape of an earth, generally it is in the form of a ball. It is in the form of a volleyball, or it is in the form of a something, any ball, it is a green ball. So now this particular shape is known as oblate spheroid. Oblate spheroid or oblate spheroidal. The shape, true shape of a earth is oblate spheroidal. So now here, suppose if you want to calculate the height of an object over a surface, now here it is exactly oblate spheroidal, but when we go for the practical conditions, in no case, in no area, we may not having a particular level, ground level. So that may not exactly be flat. For suppose if I take the original figure, original area, so it may contain so many elevations. Some position it may be having the flat, and in some position that may be just lies above the ground level, and some position that may be below the ground level. Likewise, and its continuation. So see here, when I take a particular section, I am going to consider this particular part. So the part between these 2 brackets. So this part I would like to consider now. So this is not exactly the exact curvature position. We have so many animations over there. And it is not exactly the flat. So if you measure a body's height, or if you measure the length of a particular area or anything, what happens means automatically here you will get some errors. Why? Because the length that is measured over the straight ground is not equal to the same length up to the same position. So let us take this is some L1, let us take this is some L, A position, B position, some B dash position. So here these 2 points are parallel to each other. But whereas here I have L1, but L1 is not equal to L in no case. That is only because of here I just calculated a straight distance and a sloping distance. So likewise here I have a ground level somewhere else like this, and now it is containing some sloping particulars. So because of this particular, first suppose if I want to measure the distance between these 2 points, so this ground is actual, assumed ground is exactly straight, but whereas the actual ground is not straight, it will be having some slope. So therefore the distance measured over the ground level, you will get some errors. That is the first thing. And second thing is, now I am going to talk about some practical condition. Let people go and stand in a playground, so that we can identify the playground surrounded by you is really exactly flat. So I am going to draw. So let us take this is a surface. This is a surface of a football court. Football court. So how it will be? It will just very flat. Okay. Then suppose if you want to if you want to expand it into a number of times. First suppose add another football court, another football court, another football court, and extend it to until infinity times, infinity number of times. So see here. Now I would like to tell you that let us assume that the position of this particular court is somewhere else here. Okay. So this is the court. This is my court. Border between these 2 points. Now what I am doing? I am adding. I am extending. I am extending. I am extending. Extending. After infinity number of times. So see here, starting point, first point, from first point to infinity number of point. So actually these 2 locations, between these 2 points, the ground is very flat. Between second and third, it is flat. Continuation flat. But when you club together and see the structure. See the structure of this particular, see the shape of this particular number of football courts, automatically you can see, you can observe that there will be some curvature. There will be some curvature. Means, reality is different. What we are saying is different. In reality, at each and every position over the ground level, we will be having some curvature. But what we are seeing is a flat ground surface. So based on these 2 conditions, means based on the curvature of the earth, based on the curvature of the earth, we have 2 main classifications of surveying, but we will not call them as the classification, we call them as primary divisions. Primary divisions of surveying. They are, first one is plane surveying, which deals with what we look at. Means plane area, plane surface. And whereas the second one is geodetic surveying. Don't count here. Geodetic surveying. So where we study about curvature of earth. Curvature of earth. So plane surveying, plane surveys, which talk regarding plane surveying. Geodetic surveying, which talk regarding curvature of earth. Okay. So in the next class, we will see what is plane surveying and what is geodetic surveying and further classification of surveying. Thank you.